Right, one of the properties that all waves do, sound waves, earthquake waves, light waves, is they do reflection. Okay, so we're going to study that now. Now, first of all, the reason we are able to see is because when light hits any object, it reflects it. So that they're showing light hitting a rose, and we can all see the rose because those little black things represent people's eyes, because the light goes in different directions and it gets to us by reflection. Now, we need to be able to know a couple of technical terms surrounding reflection. First of all, a plane mirror is basically a flat mirror, and the way we draw the plane mirror is shown at the bottom there, so it's like a line, a dashed line with a flat surface. There is, whenever you have a plane mirror, an imaginary line called the normal, okay, and the normal exists at 90 degrees or is perpendicular to the plane mirror. When you have a light ray coming in and it strikes the mirror, where it strikes the mirror is where we draw the normal from. Now, the angle from the normal to the ray of light coming in is known as the angle of incidence. Then the light, of course, bounces off, and when it bounces off, it goes at another angle, and that there's known as the angle of reflection. I should say reflection. And whenever we study this, we always find that the angle of incidence equals the angle of reflection. Sometimes this is summed up as I equals R. Now, all objects obey this law. It is called the law of reflection. Sometimes, when you fire light at a surface, it doesn't come off all parallel, but it actually seems to be going in all sorts of directions. But if you look at each of those individual waves, say look at the red one, you will see that the angle of incidence equals the angle of reflection. And the same for the pink one, and same for the green one. What's changing there is the normal, but each of those normals is always at 90 degrees to the surface at that spot. And that is known as scattering, but all the rays are obeying I equals R. Now we're going to learn something about images now, real images and virtual images. And the way to explain this is by considering someone looking at an object in a mirror. Let's imagine you were driving along, and you were looking in the mirror and you could see there was a cyclist nearby. Now, as you know, the light bounces off the cyclist and then bounces off the mirror and heads towards you, obeying I equals R. You can see the blue lines represent the rays of light, and the dashed line represent the normal. Now, our eyes can only see things in straight lines. So our eye interprets it that the light is actually coming from behind the mirror. Okay, if you follow those blue traces all the way back, you'll see they cross over a spot behind the mirror. Now, that, because it's behind the mirror, is known as a virtual image. It's behind the screen. And the distance from the virtual image to the mirror and from the mirror to the real object, okay, is the same. If you notice, it's 2 meters and 2 meters. Here's another example. If you stand in front of a mirror, what you actually see is, if you were looking at your feet, what's actually happening is the light is bouncing off your feet, then bouncing off the mirror, then going to your eye. Okay, and it again obeys I equals R. But again, your brain can only see things, or your eyes can only see things in straight lines. So it assumes that the light is coming from your foot on the other side of the mirror. So you can see that's what it looks like. And again, if you measure the distance between you and the mirror and the image in the mirror, there it's twice the distance. Okay, it's not quite right in this case here, but it should be twice the distance. The other thing to know is that the image is laterally inverted. Now, what this means is that you're not upside down, but what you find is that your image is actually back to front slightly. The way to do this is, if you take a selfie and look at yourself in a selfie, then go in a mirror, then you'll be able to see the following. So what you do is you take a selfie with your right eye shut, and then go to a mirror and then look at your selfie, and then look at yourself in your mirror, and you find that the eye that is shut is actually different in the mirror than it is in the selfie, and that's known as laterally inverted. Right, you need to know what a real image is. Now, a real image can be projected onto a screen, so you've got to memorize that. Real images can be projected on the screen, and they're formed by light focusing on a screen. So that's the difference between a real image and a virtual image. Virtual images can't be projected onto a screen, and they are behind the screen or behind the mirror, whereas real images can be projected on screen and are formed by light focusing on the screen. And that there is reflection.